Hello everyone, welcome back to my channel. Today let's go over another Leetcode medium question. This is a triplet question that just came out recently, and I'm really glad to say that I was able to solve this one on my own relatively quickly without any assistance. So yeah, really happy about that given the acceptance rate. I don't know if I'm just getting smarter or, after 1470 questions, I'm finally getting it and I was just a slow learner. I have no clue, but just really proud that I was able to come up with my own solution to this question without any assistance relatively quickly. And yeah, so again, I'd like to show you how I did it. Basically, this one is a standard triplet problem. It's called count special triplets. Basically, it's pretty straightforward. You just want to find triplets that are on the left side and the right side of J, and then are equal to satisfy these rules. So on the left is double of J, on the right also double of J, and then you want to count how many triplets satisfy those conditions. So let me show you the brute force way of doing it. So just for I in range length nums, and I did this first just to test it out before I tried optimizing it, which I was able to do. So for J in range I plus 1 length of nums, for K in range J plus 1 length of nums, again if nums of I is equal to nums of J times 2 and nums of K is equal to nums of J times 2. In that case, that's a new triplet, and then you just want to return that at the end. And obviously you have a mod, so mod 10 to the power of 9 plus 7, so modulo mod, and then run it. Okay, let's see what's going on. Nums of K. Nums of K is nums of J times 2. This is not squared, it's double. Okay, submit it. And this is n cubed because of the 2 extra loops, so obviously it works, but it's going to be too slow. So let me show you my own way of doing it. So let's let it time out. Okay, so if you make some observations here for any triplet problem, let's say we have an array here, you know that J can only be this. Why? Because there's always things that have to be to the left side and to the right side of J. These are irrelevant. Those are just the boundaries. So everything has to be to the left or the right side. These are the only points that J can be because there's going to be a left and at least a left and a right side. Here, there's going to be a left and a right side. So then that makes our job easier because we can just keep track of J. The left side is like this, and then that's it. So the left side's not going to be this because if J was here, then there is no right side, which we don't want that to happen, right? So here, same thing, the right side, if we're starting here, that's always the case. We're always starting from the second number, going to the second to last number. So that's the range for the middle element, which is J. The right is going to be this, and then, so it's going to be this, and then this. So the right is going bigger and shrinking, the left is expanding just by the virtue of the pattern. So if you know that, it becomes a little easier because what you can do is keep track of the lefts and the right sides using sorted lists. So again, nums of 1 to the n, because if you think about it, if J starts here, then the right side can only be here, right? It can't start here. That's the left side. So the right side has to start currently on J to the end, right? And then we're just going to remove the current element in each iteration to get the true right side if J is here. So hopefully that makes sense for I in range 1, length of nums minus 1. So that's doing this. And the lefts, we have to add nums of 0 because the left, there has to be at least a left side. If we're starting here, that's the left side. So then again, we're going to do rights.discard nums of I. So rights looks like this. We're going to discard the current element to get the right side. And then we want to add nums of I afterwards because lefts is here. And then after we're done, then we can add it afterwards. So if we print lefts and nums of I and then rights, okay, you can see that it lines up with what I said. So the left side here and the right side there, the left side here and the right side there, left, right. And that makes our job a lot easier because now what we can do is we want to find the double, right? Nums of I times 2. So treat nums of I as really j, which is the middle element, right? Of I and k, that's the middle. So if we want to find how many on the left side, because I has to be a lesser index than j, r is equal to double of j, and then how many on the right side is equal to double of j. In that case, we can just say, okay, so how many on the left side are equal to double of j? 1. On the right side, double of j, 1. So then you would multiply both those counts to get the number of triplets. And you'll see, because, for example, here, if so double of j is 1 and 1, you don't have 2, you have just one valid triplet, right? So here there is double of j, you don't have anything, double of j 4. Okay, 1 and 1, again, 1 times 1 is 1, so that's another 1. This is a valid triplet, and then this is another valid triplet, right? So that's the idea behind multiplying the counts of this doubled on both the left side and the right side together and adding them to our overall answer. Okay, so a little confusing, but I hope that makes sense. Basically, answer plus equals 2 lefts dot count double times right dot count double. Because if you add them together, you're going to get 2 triplets, but there's only 1 triplet here. Okay, so at the end, that makes our job a lot easier because now you can just return answer modulo mod. Okay, and as you can see, it works, but this is obviously still a little too slow because the dot count method in Python is n, I think, and we can use a hash map to keep track of the frequency on the left and the right side. Okay, I guess not. So that's interesting because last time, so I guess, okay, cool. Well, so the way I did it was I optimized it even more. I said left count is a counter of lefts, RC is counter of rights, and then we want to get this in O of 1, so we can say RC nums of I minus equal to 1. If RC nums of I is equal to 0, just delete RC nums of I. So basically, again, the number and the frequency. If it's 0, then there is no number. Delete the whole key value pair from the hash map. And then also, left count, we have to add this. So from 0 to 1, if it doesn't exist, if 1 to 2, it's already in the hash map, you get the point. So then we can just say LC double times RC of double. So now this is an O of 1 operation because we're just looking up the hash map instead of dot count, which is going to be slower. So let's submit this. And obviously that passes too. It's not going to tell you. I don't know if this is probably a pretty new question, but I'm pretty sure this is definitely faster than dot count. So yep, that's it for this video. Again, really happy that I was able to solve this question on my own. So thank you for watching and stay tuned for more.